Hey there, I'm Dave Hearn, and I'm the director of Kissimmee Park Observatory. In this Star Hopping Extra, we're going to continue on our basic astrophotography series and show you how to capture the night sky with your camera by mounting your camera on the prime focus of your telescope. More about all this great stuff right after this. Stay tuned. Hey, hello, hi, and welcome to episode 26 of Star Hopping with Kissimmee Park Observatory. I'm Dave Hearn, and I'm just beside myself to be your host. In this series of programs, we'll show you the most beautiful sights in the night sky and explain exactly how to find them with your binoculars or your telescope. So tonight we're going to do yet another episode in our new topic area of basic astrophotography and continue to discuss methods to capture the night sky with your camera. This installment will complete the initial set of basic astrophotography topics we started a few weeks ago. In the previous two astrophotography episodes, we discussed the three basic methods for taking an astrophoto, going from the most simple to the most complex. As a reminder, they are: 1. Time exposures of the night sky using a fixed tripod, which lets you create star trails or time-lapse movies. We discussed this method in the first installment. 2. Mounting your camera on a mount or telescope that's tracking the stars, otherwise known as piggybacking, which lets you take images of large deep sky objects, and we covered that topic 2 weeks ago. And 3rd, mounting your camera on the focus of a telescope, thereby using the telescope as a long telephoto lens. This allows you to capture smaller objects and get close-up images of deep sky objects, and that's this week's topic. There's a lot of details that we covered in the piggybacking episode that I'm assuming that you know for this installment, so it might be a good idea to go back and review that episode before taking in all the info we'll cover tonight. You can see the episode notes and review the video on our blog at kpobservatory.org/sh024. So mounting your camera at the prime focus of a telescope means you're essentially using the telescope optics as a long telephoto lens, which gives you much more effective magnification than using a regular telephoto lens attached to your camera as normal. The prime focus is the first focus of the telescope, essentially where the light waves first converge to form an image. When you place your camera at that point, the image focuses on the CCD of the camera and allows you to capture it digitally. Normally, this is accomplished by mounting the camera to the telescope's focuser. Then you use the focuser's knobs and the camera viewfinder or LCD to focus the image. One special piece of equipment that is needed to mate the camera to the focuser is the prime focus adapter. This comes in two parts. First, the T-ring for your brand of DSLR, which provides on one side the bayonet mount for your camera, and on the other side is a common thread. The second part is the nose piece that threads into the T-ring. The nose piece has the same diameter as the barrel of your focuser. That can be 1 1/4 inch or a 2-inch diameter. So once these components are screwed together and attached to your camera, you can slide the camera into your telescope's focuser and lock it down with the thumb screws. Make sure they're good and tight so you don't have any movement during your exposures. It's important that the prime focus of the scope can be accessed by the focuser. The distance from the front of the DSLR camera to the surface of the CCD is 1 inch or so, and to focus the camera with the telescope, the focuser needs to be able to be racked in far enough to allow that focus to be positioned on the CCD. Most commercial telescopes are set up to allow prime focus astrophotography to occur. There's lots more details to work through if your camera doesn't focus, but that's beyond the scope of this basic tutorial. If you have that situation, contact me and we'll figure it out together. Now, if all you'd like to do at this point is to take images of the moon or the planets, then you're ready to go and you don't need any other equipment because the exposure times for the moon and planets are generally very short and you don't have to guide. But if you want to do close-up imaging of deep sky objects with long exposures, there's quite a bit more effort and equipment required, similar to what we learned a couple weeks ago in the piggybacking tutorial. When we learned about using your camera for piggyback astrophotos, we used the main telescope for tracking a guide star with an illuminated reticle eyepiece. But now you have the camera attached where that guiding eyepiece normally goes. So how will we do our required guiding? Well, there are two methods, and they require completely different setups and equipment, and there's advantages and disadvantages of each. The first option is to mount an off-axis guider between your camera and the focuser. The second method is to use a separate guide scope mounted on top of your telescope. For the first option, an off-axis guider is a piece of equipment mounted between your camera and your focuser. This device uses a small prism to intercept a tiny bit of the light passing through the focuser tube on its way to the camera's CCD, and then it sends that intercepted light 90 degrees out the side to an eyepiece, normally fitted with an illuminated reticle, as we discussed before. The great advantage of this setup is you don't need to buy and mount a guide scope, so it's generally a less expensive route. It also eliminates any concern about the guide scope shifting during an exposure. I'll talk more about that in the next option. The disadvantage is that it places your guiding eyepiece very close to the camera and in parallel with the telescope tube, so it's really difficult to get your eye in there to actually see a guide star. Comfort is really important when doing manual guiding, and the strange angles that this arrangement causes can be really challenging. It's also sometimes very difficult to locate a guide star in this configuration. Off-axis guiders do have the ability to move that prism around or the guiding eyepiece around to try to find a guide star, but at the high magnifications that we use with guiding eyepieces, sometimes it's downright impossible to get a guide star unless you're shooting in a really dense star field. So the second method is to use a guide scope, generally mounted on top of your main scope. To accomplish this, you need to select a guide scope that has a long enough focal length to provide a high enough magnification to actually guide with. The scope is usually mounted with rings attached to the main scope or the telescope mount. Here's the configuration I use with the KPR reflector. In my case, I use a Meade ETX 125 compound telescope. This type of telescope uses a folded light path to allow a very long focal length in a very small package. So here are the advantages of using a separate guide scope. First, using a guide scope places the guiding eyepiece in a position easy to access for comfortable manual guiding. Secondly, it's much easier to find guide stars with a separate guide scope. The guide scope does not necessarily have to be aligned with the main optics. It can be adjusted or pointed by adjusting the screws on the rings until you find a suitable guide star. The disadvantages are the addition of the guide scope requires some additional counterweights to balance the new system. So the scope is heavier and it might tax the mount if it's too small, so you might need a bigger telescope mount. Additionally, if that guide scope is not mounted securely, it might flex during an exposure and will cause you to make guiding errors that will show up in your images. And of course, you have the added cost of buying the guide scope and ring mounting system in the first place. So which solution is best? Personally, I've always gone with the guide scope option. I've tried the off-axis guiders, but the challenges with the eyepiece angle and the difficulty in finding a guide star have proven too challenging to get repeatedly good results. I've always used good, strong, and reliable ring mounts for the guide scopes, so flexure really has not been too much of a problem for me. So that's my personal recommendation. And on top of it, it looks awesome to have that guide scope mounted on the main scope. So now that we have all the equipment sorted out, let's talk about actually capturing images. Going forward from here, I'm assuming you have your telescope mount aligned to the pole and have the clock drive running, as we discussed in the last astrophotography episode. Going back to lunar and planetary imaging, as I mentioned, this is the easiest effort because of the short exposures that are required. To shoot the full moon in a reflecting telescope, you can set your camera on auto exposure mode, and then you'll find that the exposure time is going to be near 1/1000th of a second. You can play with your camera's ISO settings to get the exposure short enough. Planets do take a bit more exposure, but you never have to really go more than a few seconds. Trial and error works best here. With planets, though, at prime focus, the image scale will not be very big, so the disk of the planet will be kind of small in your image, but it's still big enough to see the rings of Saturn or the moons and cloud bands on Jupiter. To get the moons of Jupiter, you'll need a much longer exposure, which will totally overexpose the disk of the planet, but that's okay, because now you have captured the moons. But for deep sky imaging, you'll need to take many subframes as we described last time, and then stack them in software later. The process is exactly the same as we discussed for piggybacking, which is, number one, frame up your image in your camera. For prime focus, you can use a bright star. Make sure you have a good sharp focus. It's best to focus on a bright star somewhere else, then move the scope to your target, then tighten your focus on a fainter star. Here's a great tip. If your DSLR has the ability to do a zoom on the LCD to 5x or 10x, do that and focus the star. This will make sure that you have tack-sharp star images. 2. Find your guide star in the guide scope or off-axis guider. As we mentioned, you might have to adjust the guide scope with the adjustment screws on the mounting rings. 3. Align your illuminated reticle eyepiece to the motion of the mount, so when you make adjustment, the motion follows the crosshairs. 4. Start your exposure series using your intervalometer or computer, then make adjustments using your scope's motor push buttons or adjustment knobs as you see the guide star starting to drift in the illuminated reticle. And 5. Pick your subframe exposure lengths and do as many exposures as you feel necessary. I usually try for at least an hour of total integration time, which, as we discussed last time, is the sum of the lengths of all the subframes you take. Remember, if some badness occurs in any subframe, you can kill the exposure and get started on a new one. You can just throw away the bad image during your stacking process. So with this setup, you can capture close-ups of any deep sky object, and this is what you need to do to capture most galaxies, planetary nebula, and get the best images of globular clusters. I have to tell you though, this is the most difficult type of astrophotography because since the magnification is higher, it's very easy to see any drift. The guiding has to be done with as much precision as you can achieve. If you have drift, you end up with images like this, which is not what you want. But if your tracking is good, after processing, you can end up with amazing images like these from KPO. Galaxies, nebulae, and clusters all await your camera. So now we've talked about all the basic types of astrophotography that you can accomplish. For prime focus imaging, which was tonight's topic, we first discussed the equipment needed to mount your camera to the scope. Then we talked about the pros and cons of using off-axis guiders versus mounted guide scopes. Next was basic lunar and planetary imaging, and then we reviewed the process for deep sky imaging at the prime focus. So now you have lots of beautifully guided subframes. In a future episode, I'll discuss basic image stacking and processing, which is where these individual images bloom into the gorgeous astrophotos that you see from accomplished astrophotographers across the internet. I want to do a quick shout out and thank you to Mark Gallup, who became KPO's first contributor on our Patreon site. We really appreciate your support, Mark. It really validates our work here. Thank you so much for your help. For our supporters on Patreon, we provide the scripts of every episode, free digital images of our astrophotos, and other exclusive content. For more information on our Patreon, check out our episode trailer coming up in a few seconds. And you can also find the link to the site in the show notes. So that does it for this week's show. You can find the show notes on our website at kpobservatory.org/sh026. where you can comment and leave any questions that you may have. Well, thanks for joining us, and I'll see you next week in our episode of Star Hopping.
I'm Cassie, and I hope you've enjoyed star hopping around the Milky Way. We'll continue to bring you these video astronomy tutorials every week on Thursday, and in their podcast format on Fridays. They'll be designed to help you find deep sky objects that are up in the sky at the time we post them on the internet. The reason we create these videos and podcasts is to help beginning amateur astronomers learn the sky and get more enjoyment out of their telescopes and astronomy in general. If you have any requests for potential targets in the night sky that you would like to see us discuss, just let us know down in the comments section below or on our website blog. Don't miss our free field notes for this episode, basically the script of the show, with all the images and start charts we use for our star hopping activities. You can get them for free at kpobservatory.org/fieldnotes. If this is the first time you're checking out star hopping, and if you found this video useful, please consider subscribing to our channel by clicking the big yellow button, click the thumbs up on the video, and please share this tutorial out to your friends who like looking at stars. Also, as I just mentioned, please feel free to leave any question or comment below, and we'll be sure to respond quickly. Please follow KPO on Facebook, where we post all of our astronomical digital images, and keep everyone informed about upcoming astronomical events. We'd love to hear from you to discuss all this great stuff up in the sky. All the links to these places in cyberspace, including our website, kpobservatory.org, can be found below in the episode notes as well. And finally, if you feel this video provides you value, and if you'd like to see more, please consider supporting us on Patreon, where for a small amount per video, you can support our efforts, and help us make even more great astronomy tutorials, just like this one. So bye for now, and thank you for watching, and we'll see you next time on Star Hopping with Kissimmee Park Observatory.